So what we're going to do is, so I want you to see dimensional analysis as many different ways as possible. Okay, so the first one I want to do is define what a period is. So what is a period?
Period is that's the time, right? That's how long it takes for one total revolution.
Right. So in a simple harmonic motion, any motion that repeats itself in equal intervals of time, that equal interval of time is called a period. So for example, a circular motion does this. It keeps repeating over and over again. If you were to project this motion down onto the floor, what will this motion look like? That ball goes back and forth, correct?
Yeah.
That kind of motion is called simple harmonic. Like a sinusoidal wave, this kind of a wave, will be simple harmonic, because every single time this wave goes from crest to crest or trough to trough, it covers an equal amount of time. And so the period is very important to understand when you're talking about simple harmonic motion. So let's start at the very beginning. Let's start at the most simplest of things that we did at the beginning of the semester, which was centripetal force, right? So there is a mass attached to a string, and it is moving in a circle. So there is a radius r, and there is an angle that it traverses through that we usually call phi. So the period of this system is the time that it takes to complete how many degrees?
360.
Or 2 pi, right? So yes, the period is the time it takes to complete one revolution, which is 360 degrees or 2 pi radians. Now, if this mass is m, what does this motion depend on? So if I want to find the period of this motion, what does this motion depend on? So the period depends on, okay, let's start at the beginning. So imagine this is a motion that's happening in the XY plane, okay? So this motion depends on, the first thing that should come to mind is how heavy the mass is. And two, how fast it's going. So its velocity or its speed. And number three, it could depend on radius, r. And number four, I'm going to put it as a sweep angle. That means I can write this as T is proportional to M, V, R, and phi. And then we always do alpha, beta, gammas, because we don't know what alpha, beta, gammas are. And all we have to do now is figure out what values to put in here. Okay, now one thing you need to know about dimension analysis is the dimension analysis does not necessarily know how to deal with angles, so we just ignore them. We put this equals to 1. Because in dimensionally, remember, we only had 3 dimensions that we worried about: mass, length, and time. So in dimension analysis, we usually put the angle as 1. We now have to write everything in dimensions.
Yeah.
So then that means I have to do m to the power 0, L to the power 0, T to the power 1. So then that means I will have M alpha, V will be written as L beta and T minus beta, and R will be written as L to the power gamma. Combine the like terms. What do I get? M alpha L beta plus gamma and t to the power minus beta. Now I can equate powers.
Yeah, you don't say that. But no.
And t to the power 1 equals minus beta, which is algebraically equals to beta equals minus 1, gamma equals 1, and alpha equals 0. What I find fascinating about dimensional analysis is the fact that if it doesn't depend on it, that power just simply goes to 0.
That happened in the homework, didn't it?
Exactly.
Yeah.
It always happens. It's like even if you mess up and choose something that shouldn't be there, dimensional analysis takes care of it. And all of these get plugged into equation A. So plug them all into A, what do you get? T is proportional to m to the power 0, v to the power minus 1, and r to the power 1, which means t is proportional to r over v. And in fact, we know, because we're talking about periods, it is 2 pi r over v.
And that's where the phi came back into play to become the 2 pi.
That is when, because we're talking about the whole 360 degrees, so the constant, you know how the proportionality becomes equals, right? You have to put a constant there.
Oh,
In algebra,
gotcha.
right, in algebra, the way you make the proportionality go away is you put a constant there. And the constants we put there is 2 pi because that takes care of the fact that you're going all around in a circle.
That makes total sense.
And also the really cool part to look at is what is v? Nothing other than the circumference divided by the time taken. I'm going to put this in a cloud.